Algebra 1, this is outline 0.8. We're going to talk about area today. Yesterday was perimeter, the outside. Now we're talking about area, which is the inside. So I have here the list of several shapes that would come in handy to know. And if you look at the whole entire top row, they all essentially have the same formula. Basically, I'll start with the rectangle, or the parallelogram. It's length times width. Usually when we have a rectangle, we use L and W because we're talking about a length and a width. But if I go to a parallelogram, we call it a base and it has a height. It's the same thing. It's got a length and a width. But since the corners are not 90 degrees, we like to call it base and a height. And notice that if I take this little triangle out, pick it up, and drag it over here, it would actually complete a rectangle, which would be length and width. And therefore, that's why it's the same formula. And a square is a rectangle. It's just that our sides are the same size. So therefore, it's just S times S, and S times S is S squared. Side squared. Pretty easy. I think everybody in here knows how to find the area of a rectangle. Now, when we start getting to a triangle, now again, guys, you can see that in this photo, I probably should have erased it, but the whole idea of using an X. We don't use X's anymore, right? We use dots for multiplication. But for a triangle, it is 1/2 base times height. 1/2 base times height is the area of a triangle. There are proofs to prove that any triangle, no matter if it's an obtuse triangle, an acute fuzzy triangle, or a right triangle, it's always 1/2 base times height. We can go into that. You'll do that in geotrig, actually. The next one is a trapezoid. Remember trapezoids, the top and bottom bases are parallel to each other. Notice that they both intersect the height at a right angle. So it means they have to be parallel. And there's a cool little formula there of you take the bases, add them together, divide by 2, and multiply it by its height. So it's 1/2 base 1 plus base 2. Sometimes they use B1 and B2, not Bananas and Pajamas. You guys remember that show?
No.
You guys are too young. Okay, but you have B1 and B2. So B1 plus B2, base 1 plus base 2, divide that by 2, multiply it by the height. Also remember, guys, that the order of these things, right? Length and width, base and height, or half, we can put a half up front of A plus B times H. I could take half of the height first and then multiply it to the sum of the bases. Or if it's easier to take half of the height, because it's maybe a nice even number, and then multiply it to the base, perfectly fine. And the last one is the area of a circle. In the area of a circle, we use pi. And again, we talked about yesterday how we don't want to use 3.1 for pi. We want to keep it on our calculator. And it's pi r squared. Take the radius of whatever that circle is, square it, multiply it by pi. If you want the exact answer, you leave it as 9 pi or 2 pi. If you want the approximation, then you use your calculator and figure out to how many decimals it asks you to do. Since you guys feel you are skilled in this, A through D on here, take your time, maybe 2 minutes each, maybe a minute each. Find me the area of all of those. All right, we just realized, guys, that in part C, it does not give us a height. It gives us the side length. So if I asked you for the perimeter, not a big deal. But if I asked you for the area, you guys would need to know a height component to this. And without it, you cannot find the area. So let's just say that the height, for our purposes, which I don't know if we can make it true or not, but let's just say it's 1. I'd have to run some numbers off the top of my head, but I'm not going to do that now as we're sitting here. So we'll just say it's 1. And we'll come back to that one. So the first one is a rectangle. How do I find area of a rectangle? Generically, please. It's A equals length times width. We start to fill that in. Which one's the length? Bless you. 10, using parentheses, guys, and 8, which equals 80 what? Meters squared. Yes, we need to realize that area is in units squared. Area. Next one is of a square. At least it says it is. And so, area of a square is, it's s squared, or if you really want to, you could just say it's length times width, right? But since it's easier to say it this way, it is 5 squared, because all the sides are 5, which equals what? 25 meters squared. Okay, moving to C that I adjusted for you guys. This problem would lead us to what? Area of a parallelogram is base times height. The base we are saying is, and the height we're going to call, so therefore it equals 5 inches squared. Everybody's probably doing well so far. And then we get to a triangle. What kind of triangle is that?
Right triangle.
So it's a right triangle. Tells us the base is, and the height is. So what's the formula for this thing? 1/2 BH, 1/2 base times height, which is 1/2 5 times 12. There's more than one person in the room. People help out. Fritz? It equals 30. Here's the thing. If I was going to not use my calculator, because I don't want to use my calculator, 1/2 of 5 is 2.5. What's 2.5 times 12? Yeah, gets a little wishy-washy, right? But, like I was saying earlier, what if I noticed that 1/2 times 12 comes out nicely, which is 6. And then 6 times 5 is 30, and the label on that is, Logan, centimeters squared. So the next ones are circles. One of them has a radius of 7 inches, and the other one has a diameter of 10 centimeters. Give those a try. And for both of these, the area of a circle is what? Pi r squared. It's pi r squared. Hey, we know the radius. The radius was 7. Putting it in parentheses because I'm substituting it in, just in case something ends up being negative when I'm substituting. That negative has to be taken with it. But this time it's positive. And so I square 7, I get 49 pi. And now you take 49 pi, which we could leave as an answer. 49 pi inches squared, right? That's an exact answer. But if I want an approximation, let's say to a single 1 decimal, what do we get, Parker? 53.9 inches squared. Okay. F is no different. I use the same formula. Area equals pi r squared. The only difference is I need to do what first? What do I need to do? Get the radius. 10 is the diameter. So I need to take 10 and 10 over 2, which is, so area equals pi times 5 squared, or 25 pi, and we are centimeters squared, and we multiply that by pi. Logan? 78.5 centimeters squared. Both of those answers are awesome. The last problem of this section is estimating area. So basically, this could be this red shape, polynomial there. What if that was the lake that my cabin's on, or something like that, or I water ski or rowboat across? And what if someone was asking me, how big is your lake? So what you can do is, what they actually do is they overlay it with a grid of a certain size. Like this might be in, I don't know, let's make it in 1 mile squares. This is going to be a big lake, right? So this, so every little square here represents a 1 mile by 1 mile little grid. Think about it. Anytime you've actually looked at a map of like roads and all that stuff, they're made in grids. And they have a scale. So let's just say this scale is 1 mile. How many miles? Yeah, see? It says full squares. But how many square miles is this lake, approximately? This is a little hard to do. So I got 4 steps there. It says count how many full squares. Because if you can count the full squares, you know that you have at least that much lake, right? So I go here and I'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So we know this lake is at least 14 square miles. The second one says count how many partial squares. So I'll change colors. And we were using, I'll use red this time. I've got 1, 2, 3, 4, 5. Now, what happens, and what we're going to do here, is for number 3, they actually, step 3 says treat them as being half each. They kind of look like half, at least in this picture. In some, it's not going to be. Maybe it's going to be a rounded curve of the lake. And so what you're going to do then is you can add up all of the partials. So I have 5 halves, right? 5 half, or should I say, yeah, we'll say it that way. I have 5 partials, or 5 half-full squares, which will lead me to 2.5 square miles, right? I can add that to my, was it 14? And how many then do I have? 16.5 miles squared, or units squared, whatever it is. Is that going to be the most accurate answer? Possibly not. This one probably doesn't look too bad. But sometimes you'll have a curve here. It'll curve around like this. And so each one of those boxes above would be considered a half. Even though I think we all can say this one definitely does not look like a half. I'll treat it as a half. Because we're estimating. We're not finding true answers here. Okay? So the whole idea is count up fulls, count up partials, give them a half in front, and then add the totals together. Page 28, 1 through 22, every 3. Have a great day.